Welcome again to another session on the logarithm that I started with you in the previous videos. In the previous video, we started solving some questions on logarithm where we applied the laws of logarithm that we've learned in the previous videos. And I hope you understood it and you enjoyed the lesson as well. So this is a continuation to solve another examples with you so that you can get a perfect understanding of it. So as you can see, I have some examples on the board that I want to solve with you, and I will encourage you to do all to watch the previous videos because the previous videos lays the foundation. I've done a lot of explanations in the previous videos that you need to know so that you can easily handle this session. So in case you've not watched the previous videos, please do well to watch them, and please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do well to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and tackle the questions that I have on the board. Okay, so now it says simplify the following. So the question 1, I have the log of s plus 1 minus the log of s squared minus 1. So we have to simplify it. So let me write it down and let's proceed and do it together. So I have the log of s plus 1 minus the log of s squared minus 1. Okay, and the question is asking us to simplify it. So because we are having a subtraction sign here, you should know what you are supposed to do. I've explained it a lot that immediately you see the subtraction sign, it means you are supposed to apply the quotient rule. Okay, and when you see the addition sign, it means you are supposed to apply the product rule. In this case, we have the subtraction sign, so it's the quotient rule that is supposed to come in mind. So we are going to apply the quotient rule to this one. So let's go ahead and do that. So I'm going to rewrite this one as the log of s plus 1 over s squared minus 1, and I hope you understand up to this point. Now, in the previous videos, we've already established the quotient rule or law, and the quotient rule says that having, let's say, log a minus log b, it can be written in division form as this: the log of a over b. That is the quotient rule that we've explained a lot in the previous videos. Now, all that you need to do is to write your log, then the first number becomes your numerator over the second number or variable becomes your denominator. As simple as that. Okay, so if I have the log of 3 minus the log of 2, I can simply write it as the log of 3 over 2. That is the quotient rule. So that is what we apply to this one. So having the log of s plus 1 minus the log of s squared minus 1. So write your log, then this is your s plus 1 will become the numerator over the s squared minus 1 becomes your denominator. I hope you understand up to this point. Let me clean this from here and let's proceed and simplify further. So now from here we are going to apply the difference of two squares, okay, to simplify the denominator. That is the next step. The only way to go ahead and simplify further is to apply the difference of two squares to the denominator, which is here. And the difference of two squares, I've taught this in the previous video in the topic factorization. That's the topic when we're looking at factorization as a full topic, we got to an aspect of it where we learned about the difference of two squares. So we are going to apply that knowledge here. So in case you don't have any knowledge on the difference of two squares, please take note that I've already taught this in the previous videos, okay, which is on factorization. We looked at difference of two squares. So we are going to apply that to simplify the denominator. Are you okay with it? So first of all, let's write my log of s plus 1 over, now this s squared is the minus, and this one I can write it as 1 to the power 2 because 1 to the power 2 is the same as 1. I hope you understand. So I'm going to write it as 1 to the power 2. That is the first step. Then from here, then we go ahead and apply our difference of two squares. Okay, now let's go ahead. So I'm going to have the log of s plus 1 over the difference of two squares says that this s squared minus 1 squared, I can write it as s minus 1 in one bracket multiplying another bracket s plus 1. That is the difference of two squares law. Okay, please, all that we did is to apply the difference of two squares to the denominator. The difference of two squares says that if I have, let's say, a to the power 2 minus b to the power 2, it says that you can simplify or express this as a minus b in one bracket. So you are going to write your a minus b without the powers, put it in one bracket. Then in another bracket, you are going to write a plus b. Okay, so whilst you maintain the minus sign in one bracket, in another bracket, then you change it into positive sign. So it's going to be a minus b in one bracket, then in another bracket, a plus b, which they are multiplying like this. That's the difference of two squares. If I have s squared minus y squared, I can write it as s minus y in one bracket, then in another bracket I'm going to write s plus y. That is the difference of two squares that we apply here. So having s squared minus 1 squared, I can write it as s minus 1 in one bracket, then in another bracket also s plus 1, which they are multiplying. I hope the explanation is clear enough up to this point. Now let me clean this from here and let's proceed. Okay, so now you can see that this s plus 1 can cancel the s plus 1 which is here. Okay, so this s plus 1 will cancel the s plus 1 which is here. So I have, let me continue from here. I have my log of the numerator here. What I have left there is 1. Okay, so I have 1 over the denominator. What I have left there is s minus 1. I hope you understand and you agree with me up to this point. So from here, we are going to go ahead and do a further simplification, applying the laws of logarithm, which is the quotient rule. We are going to write this in another form. So the log of 1 over s minus 1, we can write it in another form. Let's proceed and do that. So I can write it as the log of 1 minus the log of s minus 1. I hope you understand and you agree with me. Now, the quotient rule says that if I have the log of s over y, it can be written as the log of s minus the log of y. So that is the rule that we apply to write this in this form. So the log of s over y, the log will affect the s, so log s. Then you bring your minus sign and the log will affect the y, so log y. So in the same way, having the log of 1 over s minus 1, the log will affect the 1. So that's why I have log 1 here, minus the log s minus 1, okay, because the log will affect the s minus 1 also. So that is how to express it in another form, and I hope the explanation is clear enough up to this point. Let me clean this from here and let's proceed. Okay, now from the previous videos we established that the log of 1 to any base is always equal to 0. If you remember that in the previous videos, that's one of the properties that we looked at, that the log of 1 to any base is always equal to 0. So having the log of 1 to the base 10 is supposed to be equal to what? 0. In simple terms, the log of 1 is always equal to 0. Okay, so having log 1 here is going to be 0. So I'm going to be left with 0 minus log s minus 1. Okay, because in place of the log 1 is 0. And 0 minus log s minus 1 is going to be minus log s minus 1. And this is your final answer. I hope the explanation was clear enough and you understood it as well. So that's how to simplify the question 1. Okay, let's proceed and look at the question 2 as well. Okay, I'm going to clean this from here so that we can have enough space to continue with the question 2. So let me clean this and let's tackle the question 2. So the question 2, I have 2 log 5 to the base a plus log 4 to the base a minus 2 log 10 to the base a. So we have to simplify this one. So we are going to apply all the properties as well: the power rule, the quotient rule, and the product rule. So let's go ahead and start applying the power rule to move all the coefficients of the log, okay, so that it can become simple for us to simplify further. So let's go ahead. So this 2 log 5 to the base a, I can write it as the log of 5 to the power 2 to the base a, as we've explained in the previous videos. That's the power rule or law that we are applying here. Okay, then bring your addition sign, which is here. Then repeat your log of 4 to the base a minus, then this 2 will also come and become a power to the 10 here. That's the power rule. So I'm going to have the log of 10 to the power 2 to the base a. I hope the explanation is clear enough up to this point. So now, in case you are wondering or you are confused about the power rule, we've explained it a lot in previous videos. The power rule simply says that if I have, let's say, 2 log 3, the power rule simply says that the 2, which is a coefficient to the log here, can come and become a power to the 3 here. So I can rewrite it as log 3 to the power 2. That's the power rule. So if I have s log y, I can rewrite it as log y to the power s. All that we do is that the coefficient, the number or variable in front of the log, will come and become a power to whatever is here. So log y to the power s. So that's what we apply to simplify this and this. So having 2 log 5 to the base a, the 2, which is a coefficient, will come and become a power to the 5 here. So that's why I have log 5 to the power 2 to the base a, plus my log 4 to the base a is here, then minus, then the 2 here also will come and become a power to the 10. That's why I have log 10 to the power 2 to the base a here. That's what we just applied. That's the power rule. I hope the explanation is clear enough up to this point. Let me clean this from here and let's proceed and simplify further. Okay, so now I'm going to simplify further. So my log of 5 to the power 2 is 25. So I'm going to have log 25 to the base a. Log 25 to the base a plus my log 4 to the base a minus the log 10 to the power 2 is 100. So I'm going to have log 100 to the base a. I hope you understand and you agree with me up to this point. So now from here, let's go ahead and apply our product rule and quotient rule, because I'm seeing addition here, so the product rule needs to come in mind, and also I'm seeing subtraction here, so the quotient rule have to come in mind. So it's going to be, you write your log, so your log of, so I'm going to have my 25 times 4 because we are applying the product rule. It means multiplication. Okay, so it's going to be 25 times the 4, which is here. So 25 times 4 over 5, because I'm seeing subtraction here, so that brings in mind the quotient rule, which is division. So all over the 100. So this is what that we need to do. So don't forget to bring your base a. So I have log 25 times 4 over 100 to the base a. I hope you understand and you agree with me up to this point. Let me go over one more time. Then log 25 to the base a plus log 4 to the base a. Now, seeing addition sign, it means we can apply the product rule. So it simply means that we are going to write our log and multiply the 25 by the 4. That's the product rule. So that's why I have 25 times 4. Then seeing subtraction here, it means we have to apply the quotient rule, which is division. So it's going to be 25 times 4 divided by the 100, which is here. That's why we have this to the base a. I hope the explanation is clear. Let's go ahead and simplify further. You know that 25 and 100 can simplify. 25 goes here 1 and 25 goes here 4. Okay, so I'm going to have log 4 over 4 to the base a. Now, 4 goes here 1, 4 goes here 1. So I'm going to have the log of 1 over 1 is 1. So I'm going to have the log of 1 to the base a. So now, we've also learned in the previous videos that the log of 1 to any base is always equal to 0. I hope you remember that. That's one property of logarithm that we learned in the previous video, that the log of 1 to any base is always 0. In simple terms, it means the log of 1 is 0. Okay, so having log 1 to the base a is supposed to be equal to 0. So my final answer is 0. Okay, that is the simplification of the question number 2. I hope the explanation was clear enough and you understood it as well. So let's proceed and look at the example 3. Okay, so now let me do the example 3 here. So this is example 2. Let me write it, example 2. And this is example 3. Let's do the example 3 here. I have the log of 125 over the log of 5. Now, the first thing to do is that the 125, we are going to write it in exponent form. Okay, we are going to write it as 5 to the power something. The idea is to get it to look like this log 5 here, so that the cancellation or the simplification can be simple. Are you okay with it? So I'm going to rewrite this one as the log of the 125. I can write it as 5 to the power 3, because you know 5 to the power 3 is 125. Then over the log 5. Then from here, I'm going to apply the power rule. Okay, so this power 3 here can come in front here. Okay, it will move and become a coefficient to the log here. So now I can rewrite it as 3 log 5 all over log 5. I hope you understand and you agree with me up to this point, so that this log 5 and this log 5 will cancel away. So what I have left there is 3, and that is my final answer. So that's how to simplify the example 3. I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share the video as well. I'll see you again in another video whilst we solve other questions. Bye bye.